If you were expecting my colleague Murat to be here, then I'm really sorry he can't make it today. So if you came to see him, you're going to be very disappointed. You've got me instead. He unfortunately wasn't able to make it all the way from California, so I'm going to be doing this presentation on his behalf. I'm having a slight problem with my computer. It doesn't seem to be charging, so if it dies, that's when we start doing questions and answers, okay? That's the signal. So forgive me if it dies halfway through. The battery on this thing is not awfully powerful. So let's get started, shall we? My name's Alex Theedom. I've got a safe harbor statement. Everybody's got one of these. I wanted one, so there we go. I've got one. So, okay, I'm Alex Theedom. I'm a senior Java developer for a company called Indigo Cocoa. We develop online platforms for lottery systems. We're currently based on a small, tiny little island in between England and France called Jersey. You may know of it, you may not. Most people don't. Just Google it and you'll find it. It's very small. And from time to time, I go to conferences and I talk about various topics. Normally, I talk about this particular topic, which is the topic we're going to talk about today, which is Java EE Design Patterns and how the latest edition of the Enterprise edition has revisited the classical implementation of design patterns. Okay, these are some of the conferences I've been to, and this presentation is also available online from the various websites that I've been to. So if I don't manage to get through all of the slides today, you will be able to check out the rest of the presentation from the other ones I've done at various other conferences. So I'll try and get through all of the slides. There's so many things I want to say, I might get distracted, so bear with me. We wrote a book, Murat and I, called Java EE Design Patterns. Has anybody purchased this book? Oh, you have? Oh, fantastic. Excellent, well done, thank you. If you haven't, you can buy it at Amazon. It's currently on discount. I think it's about 40% discount at the moment, so grab it while you can. Otherwise, if you don't like paying for books, you could probably Google the title and find a PDF or a BitTorrent. But that's the way it is. That's how it goes. Failing that, if you are honest and you do still want a copy, but you don't want to pay for it, you can win a copy today. Okay? So at the end, we're going to have some questions and answers, and the person who has the most interesting question gets to win a copy. And it's not a cheap book. It's normal price is about 50 euros, although currently it's actually on discount at Amazon. So without further ado, let's continue. So what am I going to talk about today? I'm going to talk about a little bit about design patterns and where they came from and what they're all about, just to sort of get us all up to speed so we know what we're talking about. And I'm going to try and map classical design patterns, the GOF design patterns, to their implementation in Enterprise Edition 7, and to show you how they have changed quite substantially, and how Enterprise Edition now gives us a very simple way of implementing design patterns that we all know and love and learned at university or wherever, and we use every single day, but how they are now implemented very simply and quite often with additional enhancements that make our lives a little bit easier. I'm going to talk a little bit about context dependency injection, because this is really what gives us the power to implement these patterns in this new way. And in order to demonstrate this, what I'm going to do is talk through some of the really simple patterns that we know, the basic classical patterns: Singleton, Factory, Facade, Decorator, and Observer. Anybody not familiar with these patterns? Doesn't matter. They're very simple, and I will give you a very quick sort of motivation for why these exist, and then how they're then implemented now in Enterprise Edition. Then hopefully, if we've got time, final conclusions, then questions and answers. So before I start, I've got a nice number of people here, which is good. I kind of like to find out exactly where we are with the Enterprise Editions that we're using. So those of you who are still using J2EE, hands up, please. Only 1, 2. Do you work for banks? Yeah, no. Banks love old editions of Enterprise Edition. Who's using current editions? EE 5, 6, or 7? There's a few of you. Who's using 7? Oh my goodness, that's more than I expected. Well, yeah, I mean, a year ago when I started giving this talk, nobody was using 7. everybody was still on J2EE, but it seems like the adoption of Enterprise Edition 7 really has taken off quite substantially over the last few years, and there are quite a few adoption stories, really positive adoption stories, that you can find published on the blog of Reza Ryman, who wrote the foreword to my book. He's very interested in promoting EE7, and some interesting adoption stories are there. So if you have an interesting adoption story, by all means contact him and let him know what your experience was and share it with everybody else. And who's using Spring? Yeah, that's pretty much the response I normally get, pretty much everybody. So that's great. I like Spring, it's a great framework. But let's have a look at Enterprise Edition, because that is also coming of age. So, what are design patterns? How did it all start? Did they just appear magically from nowhere? No. Well, design patterns, as you know, have their history in architecture. That's the real architecture. The architecture actually builds something physical, not just the software architecture. So they've been around for ages. You know, they provide us with patterns on how to do things. But it wasn't really until the Gang of Four wrote their seminal book, Design Patterns, Elements of Reusable Object-Oriented Software, that design patterns really actually came into the fore in the Java arena. They talked about design patterns in terms of creational, behavioral, and structural, and divided patterns up into those. They wrote a book with 27 patterns, if I remember correctly, and they fitted into those three categories. So why do we need design patterns? What are they for? What's their practical? Why do they practically exist in terms of software development? Well, they're solutions to problems already solved. Okay? They represent the collective wisdom of developers who have come up with ready solutions that we can then implement in our daily lives. But also they give us a common vocabulary, not just among Java developers, but among all developers. If I say singleton to a C program, they know what I'm talking about. If I say factory to a C# program, and they also know what I'm talking about. We know we don't need to explain what these things are because we know what they are. That's the common vocabulary that it gives us. The implementation for each language is specific, and as you'll see today, we're going to be seeing how in the Enterprise Edition of Java, that implementation is very, very unique to that framework. So, after the Goff published their book, there was a very important presentation at JavaOne 2000, which talked about the prototyping of design patterns for the J2EE platform. This was actually a very, very successful talk that covered just the enterprise patterns. And a year later, they published the book called J2EE Design Patterns. Well, many of the design patterns that Goff discuss and talk about are actually now baked into the API within the Enterprise Edition of Java. They're now available out of the box. And this is really the crutch of what we're talking about today, is how we've got from a situation where Goff wrote about implementing design patterns using code to now, in Enterprise Edition, we're implementing design patterns which effectively are annotation-driven design patterns, or implementing design patterns with annotations. So, Enterprise Edition has simplified substantially the programming model. We now have got rid of XML descriptor files to a large extent and replace those with annotations. Convention over configuration now makes our lives much easier. We don't have tedious manual configurations of our services. And CDI hides the creation of objects. It divorces or decouples the creation of an object from the point at which it's being used. And these resources are created by the container and then injected in positions, injected in qualifying injection points throughout your application. As you will see later on, what you will find is sometimes you need to disambiguate your injection point. You need to either disambiguate or you filter your injection point using qualifiers. We'll see how custom qualifiers are used throughout the implementation of design patterns in Enterprise Edition. But essentially, what you have is in your container, you have a POJO, and your container will look at your POJO. It will create an instance of your POJO and make it available for injection, as long as it conforms to JSR 299 managed bean specification.
Sorry to interrupt you. Can you just verify that your laptop is charging?
Yes. So yeah, it will instantiate your bean. And you don't need to give your bean any special annotation in order to make it injectable. It just has to conform to that requirement of that managed bean specification, and the container will magically create it and will make it available for injection. However, you might not actually want to conform to that specification. You might want to create some object, some instance that actually you would prefer was unique. Perhaps you want to create a list, and you want that list to become injectable. Well, you can do that. We have something called producer methods, which, when annotated with the producers, annotation produces an injectable object that is made available for injection. Okay, and we'll see more about that later when we talk about the factory pattern. So let's get started. Singleton, love it or hate it, it exists. You can't get away from it. It's one of the most well-known patterns. It's used extensively by frameworks such as Spring. And it's used in loggers, it's used in pool managers, it's used everywhere. Now the motivation for this is that it creates a single instance of this object that exists within your application, exists within your JVM, and there's only one that's shared across your JVM for your particular application, and it's only ever instantiated once and lives for the life of your application. However, because you're operating in a multi-threaded environment, you need to be really, really careful about thread safety. You need to make sure that when it's created and when it's accessed, you're taking care of these concurrency issues. Now, the traditional implementation of a singleton requires some quite unnatural and quite uncomfortable constructions. You might use private constructor, you might use double-check locking, you might have to use static initialize. There's a lot of code in there, which is effectively boilerplate code. And wouldn't it be nice to be able to not actually have to have that kind of code which you've written so many times before and probably just copying and pasting from a previous project. I mean, we're not allowed to copy and paste, but that's potentially what we're doing is we're rewriting the same code over and over and over again. So wouldn't it be nice if we could just simplify it and do something like this, what I'm going to show you. So here, this is a very sparse class that I want to make as to be a singleton. Okay. Now, if I wanted to actually, one thing I ought to mention before I continue is actually one of the motivations for the singleton is to construct heavy objects. Okay, you want a heavy object constructed that's kind of heavy, it's expensive to construct, and you want to keep it available in memory so that it's available for your clients to use. The construction is heavy, maybe it's time-consuming, it may not be very performant, but one of the motivations of the Goth pattern is to have this object constructed and available within your JVM. So what we have here is we have a very sparse class, and we want it to be a singleton. So how would we normally do this? Normally, we would have perhaps some kind of static variable there, which would hold a reference to our expensive object. In our expensive object method, we would probably construct our object. We'd use double-check locking in order to make it thread safe. I mean, there's a lot of boilerplate code going on there, a lot of code going on there. And what we really want to do is just this. What we really want is just to say to our container, this is a singleton, it's a thread-safe singleton, we only want one instance of this in our JVM. This is all we really want to do, and this is what we do. In Enterprise Edition, we simply say singleton, it's a singleton. And the container knows what to do. It knows that only one instance of this object is going to exist because we've told it that's singleton. So simply adding singleton gives us a lot of benefits. By default, it is read-locked, and access is serialized. So if two threads access, they are forced into serialized access. Okay, and then when we want to use it, we just inject it here into our client. And our client will then call various methods, which are not shown here, in order to be able to get access to our expensive object. So how do we construct the object? Well, we identify a particular method that contains the business logic that constructs our object. We identify this with post-construct. Okay, I have to identify this post-construct. This method gets called by the container after the construction of the singleton, but before injection, essentially before injection. But one of the issues with this is that by default, or by convention, singletons in Enterprise Edition are lazily initialized. This means that they're not constructed until they are injected. So the first time it's used, first time it's injected, this method here, this construct expensive object method is executed. So you have a slight delay. Now, in most use case scenarios, that might not be a problem. But if it is, you can specify here to create the bean at startup. So when your container starts up, it looks for these singletons that are annotated startup and will construct the startup and construct the bean at startup, making it available to your clients. And it is guaranteed to be constructed before any client requests are satisfied. However, we might also think, well, actually, constructing our expensive object requires that I connect to a database. Perhaps there's some data there that I need. Perhaps I need to connect to some web service, or some other bean needs to exist in order for me to be able to successfully construct my object. So what we can do is we can actually say, don't construct this until we have a successful construction of a bean named database connection bean. So we can make the construction dependent on the existence of another. Of course, if that bean does not get constructed successfully, our construction, our logger fails and deployment fails. Okay. So far, we've seen a lot. So far, we've seen how very, very different the construction of a singleton in Enterprise Edition differs from the classical implementation. There is actually no boilerplate code at all. You're not controlling concurrency. The container is controlling your concurrency. You're only constructing one instance, and the container is constructing it for you. And the container is executing your creational logic because you identify which method creates that expensive object, that creational logic. So it's actually very different. And we've got some nice characteristics. We can specify when to create the object, and we can specify to make its creation dependent on the successful creation of another object. So we're actually adding functionality to the singleton pattern that we wouldn't easily be able to get in a classical implementation. But we can go further. We can take back control of concurrency management from the container. Okay. If we are that way inclined and we like to control things ourselves, we can do that. We can take back control. So we either have container-managed concurrency or we have bean-managed concurrency. So to specify that we want bean-managed concurrency, it's managed within our bean, we just simply specify with an annotation concurrency managed type bean. If you want it to be managed by the container, we don't have to specify anything because that is the convention. However, we're still operating within a concurrent environment, so method access is important. And this is controlled by two lock types. You have a lock type write and lock type read. Lock type write we use on methods that are likely to affect change, and read on methods which literally just obtain values from the singleton. However, what happens here is the access to the add message method is blocked and waits until it's completed before it serves another thread. This could result in a concurrent access timeout exception. But we can control that too. We can add in an annotation that defines how long we should wait before we give up and throw an exception. Here I've defined 30 seconds is how long we should wait. And you can have control over this. So what I want you to take away from this is that even though the container configures a lot of things by convention, it also gives you back the control if you want it. So you're not stuck doing what the container wants you to do. You can continue developing things in whatever way you so wish. But it's made much simpler because of the principle of convention over configuration. So let's have a look at the good, the bad, and the ugly. So what is good about this? We've got enhanced annotations. They give us specialized features over our application, over our instantiation of our object. We can control its startup behavior. We have fine-grained control over its concurrency. We can specify its timeout. We can specify either at the class level or at the method level the lock type. And there's substantially less boilerplate code. In fact, there's nothing really. So what we're doing is we are spending more of our time focusing on implementing our business logic, which is what adds value, than simply repeating what we've done so many times before, writing the same logic, the same code over and over again. We only have to put in a few annotations, and we have something that would take quite a few lines of code. So it offers some efficiency saving, I suppose you could say. Okay. So what's bad about this? Overuse can cause problems. Well, yeah, okay. That's always been the case with singleton. That's always the case with anything. You overuse anything, you're going to cause yourself problems. But you overuse a singleton, you're going to cause problems without your application. Too many singletons can cause a lot of problems. Lazily loading. This also can cause delays on first use. However, that is solved by eagerly loading your your singleton at startup. But then again, this also has the problem that you have this big, heavy object sitting in memory. You may never use it, or use it very rarely, but it's sitting there, it's using up space in memory, it's not being garbage collected. So again, there are some pros and cons to this. And what's ugly about it? Well, it's considered an anti-pattern. You can argue both sides of this, but it exists and it is useful in certain niche use cases. You have to decide yourself whether you want to use it or not and how you want to use it. But it may actually be smarter to use to use a stateless session bean rather than a singleton, because that offers similar services to a singleton. Session bean, stateless session bean, for example, is transactional. There's one instance within the JVM, it's pooled, so you've got a lot of benefits that come with using a session bean. But that's not all. We can have a look at let's have a look at the factory pattern. This is another pattern which has actually received change from the development within the Enterprise edition. So what is a factory pattern? It's a creational pattern. It's designed to encapsulate the logic of creation. It decouples the creation of an object from the client. So over here, you're creating your object. And over here, you're using it. And perhaps somewhere in the middle, you've got a method that's calling the factory, saying, give me this object. And the client doesn't care about the creation of the object. The client just wants the object. He just wants it so it can use the services that the object provides. So clients are decoupled from creation. Now, doesn't that sound familiar? Isn't that really what the CDI framework is doing? Isn't the CDI framework creating an object over here, making it available over here? And the client over here doesn't really care about how it's being created. The container creates it. So you could argue, if you really want to, that CDI framework is a factory. It implements a similar kind of logic. But let's have a look at a very simple example here that will lead to something else that I really want to talk about, which here we have a drinks machine interface, which is implemented by our coffee machine. And the container will instantiate this coffee machine as an object and make it available for injection in any qualifying injection point. And the qualifying injection point here is identified by the interface. Okay, so it finds, okay, this is my object, and here's the interface. It matches it and injects it. However, what about if you have multiple concrete implementations? This is often the case. Here we have coffee machine and soft drinks machine implementing the same interface, and the container doesn't know which one of these two concrete implementations to inject. Is it going to inject the coffee machine? Is it going to inject the soft drinks machine? Well, it doesn't know. It's going to fail with, what's the name of the exception? Ambiguous dependency exception at startup. It's going to complain about it. But there are solutions to this. Qualifiers. Qualifiers are custom annotations. They allow us to create a way of disambiguating between concrete implementations of the same interface when programming to an interface. This, for example, creates a qualifier called soft drinks, and this one called coffee. Now, what we see here, just so I can clarify, is the target identifies the location within your code where you can use this qualifier. Here, I've identified it can be used on the method level or a field, but also parameter and type are also available. And defining the retention policy as runtime makes it available, makes the annotation available to the JVM throughout runtime. So what do we do with that? Well, we annotate respectively our concrete implementations. Coffee, we use to annotate the coffee machine, and soft drinks, our soft drinks machine. And then we annotate our injection points. As we can see here, we're using soft drinks to communicate to the container that what we want is the soft drinks implementation of the drinks machine interface to be injected here, and likewise the coffee implementation to be injected here also. So we've disambiguated. We've helped the container identify where it should inject our object. Now, there are more uses for qualifiers, which we'll have a look at a bit later. But remember what I said. The container can only instantiate and make available for injection certain types of objects, objects that conform to JSR 299. And that is likely to be the vast majority of your objects within your system. But I want to inject something else. I mean, I don't want the container to tell me what to do. I'm the programmer. I'm going to tell the container what I want to do. And I want to inject a collection type. I have a list of books, for example, and I want to make this list of books available for injection throughout my container. So wherever it finds a list of books, it will inject my list of books. That's what I want it to do. Or maybe I have an object that has a parameterized constructor. I don't want to change my object design. I mean, I'm the one in control, not the container. I'm the one that wants to have this design for my object. I want to make this object available for injection. So how do we do this? Let's have a look a little bit deeper. We have something called producer methods. Producer methods are methods that produce an object. They produce an object that becomes available for injection. By simply annotating our producer method, in this case getLibrary, with produces, it produces a list of books. And it makes that list of books available for injection, and it will inject that list of books wherever it finds an appropriate injection point throughout the application, throughout your application. So here it's going to inject a list of books into library, which is in our second class down here. So great, we've done that. We've actually done what we wanted to do, which is to create any object we like and then make it available for injection and take advantage of inversion of control and the contents dependency injection that we have in Enterprise Edition now. And if we want to, we can filter where we inject that book. So instead of injecting it into every location where we find a list of books, we can just have it injected into a location where it is annotated history. Okay, it's an academic example, but it shows the mechanism and how it functions. Okay, you might be thinking, well, how does that method, that getLibrary method, get executed? I mean, we haven't annotated it at post-construct or anything like that. So when does the container call that method? Well, that depends. If we don't, that depends on its scope. Now, its scope is something that it inherits from the client if nothing is specified. So by default, it's dependent scope, and it inherits the scope from the client. But we might want to specify it. In this case, what we're doing is we're specifying that this has request scope. And this means that for every HTTP request that comes into the system, this method is called, and that list of books is refreshed and exists for the HTTP request in which it participates. Okay, lasting for the duration of the request. We can annotate it session scoped for the session, application scoped, conversation scoped, and of course the default is dependent scoped. I think you can specify that if you want to, but it's by convention it is dependent scoped. So what is so good and bad and ugly about this? So what's good is easy. It's not difficult at all. I mean, it's almost intuitive to some extent. But there's also no boilerplate, which is, again, is really what we're kind of, the takeaway I want from this is that we are not writing boilerplate code anymore. We're writing code that actually does something that we want, that adds value to our clients. So we're focusing on the construction of business objects that add value to our clients. And it just works. We don't have to configure it in any way. This is something that comes with the container. It's a characteristic and feature of the Enterprise Edition that it just does it. We just have to know how to communicate our intentions to the container by using the appropriate annotations, which, as you've seen, they're only at producers is the only annotation you really need. So any object can now be made injectable. We can inject any object we like. We can create any object we want and just make it injectable to any qualifying injection point. And we can use qualifiers to disambiguate and filter, and use our qualifications to have greater fine control over where we inject our object. And it's probably worth mentioning as well that you can have more than one qualifier. It doesn't have to be just one. You can have 2 or 3, 4. You can have a number of qualifiers. So, the good, the bad, the ugly. What's bad? If you don't use qualifiers, you can instead use named attribute and specify the name of the being within this parameter here. This is not type safe. However, you might have to use this if you don't have control over the bean that you want to, over the instantiation of the bin that you want to inject, or you might prefer to use this for some other reason. Well, if you do, then you have to note that it's not type safe. Okay, probably preferable to use qualifiers if you can. And what's ugly about this? Well, object creation is hidden. Well, okay, yeah. It is. It's decoupled. That's the whole point, really, is that it's created over here, and it's injected over here, and your client doesn't care about its creation as long as it's created somehow over here. And that's fine. But the consequence of that is that sometimes it's hard to follow execution flow. You can't quite see where this object is just magically appearing, and if you've got a lot of code, it could take time to find it. But luckily, IDEs often help. In IntelliJ, for example, on the code window, you've got the code window, and on the left, you've got a little bar, and in there, you will be able to see a little icon. If you click on the icon, it will take you through to where the object is being created. So the IDEs help. If you're still programming with Nano, then you're done for, really. You're not gonna work with this, but you won't be programming with a text editor. So, how much time have we got? I've done 30 minutes. Okay, so facade pattern. I've got a few more patterns I want to go through, but I'm going to go through them quite quickly. Okay, just to give you a really good flavor of exactly how extensive this change has been. It's not just those two patterns that have changed, Factory and Singleton, but there are a number of other patterns that have also benefited from this. So I'm going to go quite quickly through the remaining patterns that I have so that you just see a taste of what's going on. So, facade pattern, right. What is a facade? A facade is a way of hiding the complex logic of a subsystem, essentially. Typically used in APIs, typically used to communicate with a higher layer. It gives some kind of abstraction over what's going on. I mean, it is basically essentially abstraction is the principle, one of the principles of object-oriented programming. So why is it so special? Why does it have its own name if it's just a matter of abstraction? Well, it's because it creates a special type of abstraction in the enterprise system. Okay? You have your application layer which describes part of your system. And it might perform functions like get order, list products, and matches certain criteria. It's kind of a high-level API that describes the middle tier of your application to users. That layer might be a GUI layer or a remote client in simplistic terms, for example, or perhaps the underlying code. But it might be very simplistic from that point of view, but the actual underlying code is quite non-trivial. Okay, so how do we implement that classically? Well, it's just a matter of having a class and naming it Facade, something Facade, essentially, is the classical implementation. Slightly more than that, but that's enough for the moment. So, facade pattern. How do we create a facade? We simply annotate it like so, at stateless or at stateful. And by doing so, what we are getting is a whole range of services. Okay? I mean, it is entirely thread safe when you access it. It will be thread safe, but it is not a singleton. Okay? How it is made thread safe, despite not being a singleton, that is beyond the scope of this talk, but essentially it involves some container magic. So it is thread safe and stateless. You will never run into thread safety problems. It is by default transactional, and it is used for that tier of the application as you would normally want those high-level use cases to be transactional. Also, it includes things like monitoring management, as well as pooling, and more importantly, defining upper threshold for pool size for these services. It is very useful for defining high-level scalable APIs. Okay, and it is an injectable bean, and is injected, as you can see, as all other beans are. So, what's so good about this? Well, it's quite simple, it's quite robust, and it gives you a range of services, like I suggested. It gives you a range of services that you would have to program yourself, or you have to think about yourself. So by convention, you're getting thread safety. By convention, you're getting pooling. By convention, you're getting all of these additional services that you get simply by adding this one annotation to your class. So what's bad about it? Overuse may introduce unnecessary layers. Well, yeah, okay. Overuse always is going to be a bad, but that's not inherent in the pattern. That's actually a design decision. So if you don't need one, don't use it. Okay? And what's ugly about it? Well, nothing really. It's quite nice. So Decorator. Let's have a quick look at Decorator. I think I've got 10 minutes left. Okay, I'm going to quickly go through this. It's a structural pattern. It adds logic to your classes dynamically at runtime. Okay, it's better than inheritance. It's more flexible because at runtime you can add functionality to objects that already exists without breaking your old code. Okay, so traditional implementation, the decorator must implement the same interface as the target. It must implement the methods and adds the new decorator logic to those methods, and delegates the call to the original object after it's decorated it. So let's have a look at how we do this in Enterprise Edition. This is my decorator. It implements the product interface, and what I want my decorator to do is to discount the price of my product. Okay. What this will do is we have to identify to the container that this is a decorator. So we simply say decorator. This is decorator. Now it knows that this is a decorator, and it's going to start to do whatever it needs to do in order to make this decorate the objects. And we do this, and we do this by identifying also the objects we want to decorate. Here, we are saying to the container, inject any bean in our system that implements the product interface. Okay. And what it will do is it will, when the getLabel method on any product object is invoked, it will be intercepted by the decorator. This logic here, the decorator logic that discounts the price by 50%, this will be executed, and then the call to the original getLabel method will be delegated to the product object. So we don't need to do anything more than just this. If we want to, we can use qualifiers to say, well, actually only products that are coffee are going to be decorated. What you might have is more than one decorator. Okay, you might be in a system where you've got a lot of legacy code and you want to decorate your objects quite a lot, and you want 1 or 2 or 3 decorators that decorate one particular object. Now, if you have too many decorators, that might be a bit of a code smell and indicate that perhaps you actually need to refactor. But nevertheless, if you do have more than one, you will need to specify the order in which they're going to be executed. And we do this by annotating priority, or annotating an intercept priority on the class. If you have more than one decorator, the lowest number decorator is implemented first, or is applied first. Okay. Now, what's good, bad, and ugly about this? Well, good. It's very easy to change behavior without breaking any legacy code. It's just a matter of writing your decorator, implementing the interface, and adding a few annotations. What's bad? Well, historically, you needed to use XML configurations, and you still can use XML configurations to define the order in which your decorators are to be applied. However, it's not absolutely necessary. If you want your decorators to be available to the entire application, simply decorate it. Simply use the priority intercept. Sorry, forgot that for a moment. And the ugly, well, overused, as always, will introduce execution flows which are hard to follow, but your IDE will help you out. Okay, again, in IntelliJ, if you're using IntelliJ, you'll find in the left column a little icon which you can click on, and it will take you through to the decorator. So, have we had enough of design patterns already? No? Am I boring you? You're lying to me. Okay, quickly, observer. Right, so what do we got? 48 minutes? No, that's 38 minutes. Okay, observer. What does the observer pattern do? Well, the observer sends messages to other objects. Okay, it's about informing about change of state in your application. Okay, something changes over here, and you want this whole bunch of objects over here to know about the change of state. So you're passing messages. So what's this? Well, basically, this is fundamental object orientation, isn't it? You pass messages by calling methods on other objects. But what is so special about this? What is special about this is because we want to decouple that. We want to decouple the publishing of change of state from the listener from the object that subscribes or listens to it or wants to know about it. Okay. Now, in a classical implementation, what you would do is you would have the objects that want to be informed of this change of state implement a subscriber interface, and that would have a notify method, for example. Call it notify or update method. Those subscribers would then register with the publisher. Perhaps it will be a list, and in simple implementation, there will be a list of those subscribers, and whenever there's a change of state, the publisher would call the notify or update method on each one of those subscribers and send a message through. Now, that isn't really very decoupled, is it? Because the object that is publishing knows about the existence of the subscriber. A better system would be to be able to publish a message, and some subscribers somewhere are somehow listening to and waiting to receive that message. And that's what we can do. In Enterprise Edition, we have a way of publishing events throughout our system and a way of listening to those events. Okay? So essentially, this is the observer pattern. There are other patterns that you could call this, but I'm calling it observer pattern. How do we do this? Well, in the publisher, in the service that's going to be publishing notifications, we create we inject our event system, our event object. Okay, and what we're saying here is we're going to be publishing out an event of type string. Okay, in a real application, it wouldn't be string; it would be a custom object that would contain useful information about the event that has occurred or the information you want to transmit. And then we fire an event. We fire out our signal by calling the fire method of the event object and passing into it the message we want to publish to our listeners. Okay. So what this does is when you call the producer method, it fires off a text message. Okay, it fires off a text message throughout your system. And how do we listen to that? This is how we listen to it. Any class or any method that is annotated as so, with observes, with the appropriate parameter type, in this case string, because that's the type of notice that we are publishing out, this will receive that message. Okay, so here we're sending out, take me to your leader. This one will receive that message and act upon it. And any other method that has a similar signature to this one will also receive the same message. So what are we doing here? Essentially, actually, before I continue, we can also use qualifiers. Qualifiers to filter. Again, qualifiers come in and make our lives a little bit easier and make our lives a little bit prettier. So we're firing a warning message. Okay? So this is going to be listening, this observer is going to be listening to any message that is fired of type string that is associated with a warning message qualifier. So what's good about this? Well, it's very easy. There's no boilerplate code, as usual. There's just a simple method that, when executed, fires off our message. In a real situation, it will be a useful custom object with its own configuration. But this is effectively some kind of messaging system, isn't it, really? So if you think about, I don't know, Rabbit, for example, or some kind of messaging middleware, you have a message which you put onto to a bus, however that's implemented, and then on the other side you have a consumer that is listening perhaps on a queue and will pick off the message from the queue. So it's very similar to that and operates in a very similar way that they're both divorced. I mean, the publisher doesn't really care if anybody's listening. You know, it's just sitting there publishing out messages, talking and talking and talking. It doesn't really care if anybody's listening, okay? There might be somebody listening, there might not be, but that's not the point. It's irrelevant. It's decoupled. It doesn't care. It doesn't need to care. And the listener equally is sitting there listening, and it doesn't care if no one is speaking because, you know, that's what it does. It just listens, okay? And this is essentially what we've got here. But it's a very, very lightweight messaging system. So if you've got a situation within your application where you want to be able to send out messages throughout your application, but you can't justify implementing some kind of messaging system, then this is a great, great tool to use. It's very lightweight, very easy to implement. and also what's worth mentioning as well is it listens to transactional events. So if you have transactions in your system and things go wrong, it can listen to those events going wrong and react and do things. Okay. Again, what's bad about it? Well, okay, confusion regarding execution. Order, yeah, IDE will help you out again to find out where things are coming from. And what's ugly about it? Nothing. It's beautiful. Okay, I won't go through entity. Final conclusions before questions and answer. Efficiency savings. It's going to require a lot less code to achieve the same thing, and with less code, you actually achieve more because you are now having greater control over the behavior of your patterns and over the implementation of those patterns and the way they react and respond to things that are going on. And you have new features and enhancements. Okay, I mentioned that already. So, I made it. Okay, excellent. How much time do we have?
1 or 2 minutes.
1 or 2 minutes. Okay, so if you want to win a book, this one. Okay. Can the camera pick that up? Okay, good. If you want to win a book, ask me a question.
Okay, you said that you didn't require boilerplate code, but from what I saw of your qualifiers, they contain quite a lot of boilerplate. So what's that? Is it just a way of hiding the boilerplate code, or what?
Well, I mean, if you're talking about in terms of boilerplate, yeah, I mean, I understand what you're saying, but when I talk about boilerplate, what I'm talking about really is classical code that you would have to implement every single time. It's not going to be totally clean in terms of it's got rid of everything. I mean, nothing is that good, okay? But it's a lot better, okay? You've got to admit that. It's a lot better than before, because the real objective of this, and the takeaway I want you to have, is that what has happened is that we can now focus our attention on what's actually really important, and that is business logic. That's what we get paid to do. We don't get paid to write singletons. We don't get paid to write double checking locking mechanisms. We get paid to make applications that our clients want and to write business logic and solve business problems with code. And that's really what it's all about, is actually getting rid of all of the unnecessary code that we don't really need, that we've done hundreds of times before, that doesn't add value, and replacing it with something that's actually much simpler. But okay, it's not perfect, but it's good.
So which pattern did actually make your life easier? Like which one is your most favorite pattern?
My favorite pattern, yeah. Well, to be honest with you, I love them all. They're great. I love patterns. They do actually help resolve a lot of issues without me having to actually figure it out myself, okay? As developers, we like our lives to be a little bit easier, and we like to go home on time and see our families. So if anything that can actually help us to achieve what we want to achieve quicker and more efficiently and reduce the number of bugs because we're actually writing this code, then it's great. So I suppose Singleton is really probably the one that has impressed me most in terms of its conversion from horrible, ugly code that we used to write in the past to something that is actually quite beautiful with lots of really nice, pretty annotations that make our code look quite nice. So I guess if I had to choose one, I'll go for the aesthetic appeal of the Singleton. Are we out of time now? Yeah. All right, okay, so I have to award this book to somebody. I have to admit, I do actually quite like the question about what is your favorite annotation? What's your favorite pattern? So if you would like to come up here and claim your prize, everybody give him a round of applause. Thank you very much. I'm going to be around all day, so if you find me and you have any questions, then by all means corner me, and we can have a chat. Okay? Thank you.